Hey students, this is lesson 10.5, trigonometry and area, and we're going to learn how to find areas of regular polygons and triangles using some trig. Go ahead and do this review. You can check back for your answers. All right, so we're going to find the area of this octagon. It's a regular octagon. We need to know that. And we're going to use a little bit of trig to help us get the important information. So our plan here is to use this formula that the area of a regular polygon is equal to 1/2 the apothem times the perimeter. So we need to know the apothem and the perimeter. The perimeter, that's not hard. We can get that right away. That's just 7.5 times 8, which is equal to 60. So we got that. To get the apothem, we're going to use a little trig. So part of my plan is to use trig to find the apothem. All right, so let's just draw in a couple of things here. So here's the center. There's a couple of radii there, and call that C. Now we can find this angle right away there by just doing 360 divided by 8. So let's call that x. The measure of angle x is equal to 360 divided by 8, and that's equal to 45. Now let's draw the apothem in right there. That's of course a right angle, and if we do that, this angle is bisected, so the measure of that angle is 45 divided by 2, which is 22.5. So that angle is 22.5 degrees. We'll label our apothem A. And we can also find this measurement right here, that shorter leg of that right triangle. That's half of 7.5, which is 3.75. And then we have a right triangle. We know one side. We have a missing side. We know an angle. And with respect to the 22.5 degree angle, we know the side opposite that. That's this. So that's the side opposite. And A is the side adjacent. So we have the tangent. So we're going to say the tangent of 22.5 is equal to the side opposite, which is 3.75, divided by the side adjacent, which is A. And then just rearranging that a little, we know that A times the tangent of 22.5 is equal to 3.75. And A is equal to 3.75 divided by the tangent of 22.5. So we now have A, we have P, and we can use the formula area equals 1/2 A times P. So we're just going to substitute in. Area is equal to 1/2. A is 3.75 divided by the tangent of 22.5. If I use the whole thing right now, it'll be a little more accurate when I'm rounding in the end. And then times the perimeter with it, which is 60. And if I use my calculator to do that and I round it to, say, the nearest 10, I get about 271.6. All right, I'm going to let you try that. And you can check back with your answers. All right, another problem here. The gazebo at a park has a floor shaped like a rectangular hexagon with a radius of 6 feet. What is the area of the hexagonal floor to the nearest square foot? So in this problem, we're given the radius, and we need to find the area of the entire floor. So again, we're going to use this formula. Area is equal to 1/2 the apothem times the perimeter. So we need to find that A right there. I'm going to draw that in to help that out. Okay, so first thing we want to do is notice that this is a hexagon, which means this angle right here is 360 divided by 6, which is 60 degrees, which means this smaller angle here is 30 degrees. Divide that by 2 and we get 30 for that. And this is a right angle. And we also know that this, since it's a 30, 60, 90 triangle, the shorter leg is going to be half of the hypotenuse, so that would be 3. And now that we know that's 3, we can find our apothem. Our apothem is equal to, in a 30, 60, 90 triangle, the longer leg is square root of 3 times the shorter leg, so we just have to take 3 times the square root of 3. And our perimeter is equal to, there's 6 sides, and each side is 6. So that's 36. So now we're going to do area is equal to 1/2 A, which is 3 times the square root of 3, times P, which is 36. And when I'm doing that, since multiplication is associative and commutative, I can multiply it in any order I want. So I'm going to multiply 1/2 times 36 is 18 times 3 is 54 times the square root of 3. And since it says round to the nearest square foot, I'm just going to round that to, I think it comes out to about 93. You could check that. Maybe it's 94, I'm not sure, but somewhere around it. All right. I'll let you try that. I'll just start here. We're going to try and find the area of the tabletop. So we are given that the radius is 9.5. And we need to know the apothem. And we also need to know the perimeter. And our plan is to use trig ratios to find those. So I'll let you go ahead and try and do that. All right, theorem 10.8, the area of a triangle given side angle sine. The area of a triangle is half the product of the length of 2 sides and the sine of the included angle. And so the area of triangle ABC is 1/2 B times C times the sine of A, because A is included in the sides B and C. All right, so let's use that. Go ahead and write it down. The area of the triangle is equal to 1/2 BC times the sine of A. And in this case, the B and the C are 8 and 12, and times the sine of the included angle, which is 36 degrees. If I multiply 1/2 times 8 times 12, I get 48. And you should simplify as much as you can before you approximate using your calculator. So we need to do 48 times the sine of 36. And if I round that to the nearest tenth, that comes out to be about 28.2 for the area. All right, go ahead, you try that. All right, last thing we're going to do is a lesson check. Let's see what our classmates doing wrong here. It's trying to find the area of the regular pentagon, and with 8 centimeter sides, and the lengths of the leg of the triangle here are A and 4. And so the tangent of the 36-degree angle is the length of the leg opposite that angle, which would be 4, over the length adjacent, which is A. So our classmate, he or she, did adjacent over opposite, not opposite over adjacent, like he was supposed to. All right, that's it. I'll see you tomorrow.